session. We're going over fun times. We're going over the fundamentals of WAN and IP routing. From a CCNA level, and I want to make sure I say this, it's going to be really basic. There will be some details I touch on. We will, I will shoot out some terminology regarding the OSI model from a layer 3 standpoint and how routers handle it. We'll go over how, traffic is sent through, what have you. And again, straight fundamentals, right? Not exactly, maybe there's a difference within a production environment and in the real world, but this is fundamentally what you need to know about, WAN technologies and IP routing, okay? All right, let's go ahead and get started. Okay. Ryan, what am I looking at here? Tell me. Take a good guess.
You're looking at the connection from PC1 all the way over to PC2?
Going over what?
You said going over what?
Yeah.
Like how it connects from one device to the next, to see the connection, how each part connects to each part.
Okay.
In a network.
Okay, Ryan?
We're just looking at a WAN network, aren't we?
Yep. Small enterprise network with one lease line, right? So it's going over, we're going to say internet connection. That's it. Connecting two sites, connecting two LANs through a WAN. Okay, LAN meaning local area network, WAN meaning wide area network. Okay, and so that's what's used right now in today's world at our homes to go ahead and connect to the World Wide Web, right? Google, right? Netflix, et cetera, et cetera. This is how typically it looks, right? We're connecting from our local area network to another local area network, and the WAN is used to transport, our data from our network to the other network. Okay, let's keep going. Right, a couple of this diagram shows not legit how it looks, but just a conceptual view of how the lease line service looks, or how when connections look. Right, you have your local area network, right? You got your switches. You guys seen switches before, and then you have your routers right at the edge of a building, right? And of course they connect, right? And these are the connections, right, via the WAN. And you have your providers. You have your Comcast. You have your Spectrum. You got your, what's the other one? AT&T. You have plenty of WAN providers, right? And there's different technologies that can be used for the WAN.
Okay. Or your Lex, right? Lex and iLex.
CCNA level.
Sorry.
It's all good. It's all good. CCNA level. Yeah, I didn't want to say that term to get people confused. But good thinking. Good thinking. All right. One thing, and I'm sure. And Nick, thank you for shooting out that term. You guys can take note of it. In today's world, you guys will hear many people say different things, but they mean the same thing. Okay, so this chart shows an example of that, right? There's different names for a lease line, right? Lease circuit or circuit, right? We got serial link or serial line, point-to-point link, T1. We have a WAN link, or we have a private line. All of these things mean the same exact thing, right? So if you hear somebody say it or what have you, or say probably a different term on this list, it means the same exact thing. Okay, I won't go through each bullet point, right? Right, you guys can go ahead and take a look at the recording. But again, this is the different names for a lease line. Okay. All right. So big picture, right? So like Ryan and Brian was saying, right, and along with Nick, right? This is how, if we have, let's say customer site 1 is Maurice's house, right? And customer site 2, right, is Netflix, right? Mo is trying to watch Netflix, right? He's trying to watch Netflix and have fun, right? All it's doing, right? All what WAN technology is doing is transporting your request from here, right? And it's getting it to here, right? And we pay that money for the WAN providers, right? Would that be telcos or different companies to go ahead and transfer that to your destination. And they have agreements with different organizations that would have you so that you can go ahead and reach your destination. Okay. All right. And that's the simplest way that I can put it. Right. But again, this is a possible cabling inside of a telecommunications company or a telco for a short lease line. Okay. All right. Let me go ahead and clear this, clear the drawings. Let's keep going. Any questions, guys, so far? Again, these are just fundamentals. Of course, there's more details in the chapter, but I want to keep it one at a CCNA level. And these sessions, I want to keep it as high level as possible. Reason being because I don't want to take too much from the book, because I know you guys are, one, going to read it, and two, whenever we go into the lab, that's when I'm going to leave more room for myself to go ahead and dive deep. Okay. Any questions? Okay, we'll go ahead. All right. So wait a minute. Let me do this. Okay. So we have switches, right? Fundamentally, they operate at layer 2. Okay. Routers, fundamentally, they operate at layer 3. Grab my marker real quick. Right. So we got switches. We got routers. Okay. And so, right. So how does a router or a switch handle interacting with different layers, right? How does the switch know to handle something that's destined at layer 3 that needs to go somewhere else, right? Or how does a router know where to send something that's destined, that's based on something at layer 2, right? How does it know, right? And so again, adjacent layer communication, right? And we talk about encapsulation and de-encapsulation, and they work together in unison to go ahead and say, hey, this is where this needs to go, or this is how this needs to go, right? Typically within, right, each layer, there is a section, right? Whether that be in the header or a trailer, right? It's typically in the header, right? For each layer, that's going to say type, right? Hexadecimal value, or maybe a decimal value, right? Depending on the layer, right? And so if we go back, there we go. We go back, right, to what I really wanted to show you guys. Where are we? There we go. Okay. And so, right, so a router, right, it communicates at layer 3, but right, if we're still talking about that same example, if Maurice is trying to go ahead and reach out to Netflix, right, it gets to his router, right? But how does the router know to go ahead and put it on the wire, right? There's two type of layer 2 protocols that fundamentally a router would use to go ahead and properly encapsulate that data, right? To go ahead and be able to encapsulate it in the layer from layer 3 to layer 2, and then put it on the wire. From a router standpoint, right? 2 protocols, HDLC and PPP. Okay, we'll go into details about that later on. I just wanted to make sure that I went ahead and touched on those 2, right? And we'll go into detail with just HDLC because that's just the most recent. Okay, and so again, at a fundamental level, lease line providers, right? WAN providers, whatever you want to call them, they're providing a layer 1 service, right? Mo wants to reach out to Netflix. Hey, Mo, I'll go ahead and make sure that you can reach out to Netflix. Done. Right? And so again, these routers that these providers provide to us, right? They're going to go ahead and either use, they're going to use IP routing, they're going to use layer 3, but then for them to communicate, put stuff on the wire, they're either going to use HDLC, high level data link control, right? Or PPP, point to point protocol, right? And again, what's the job of layer 2, right? To make sure that from its source to the destination, from a layer 2 standpoint, that data, that payload gets exactly to the destination, right? Correctly. No mishap or no what have you, right? So we can't just, from a router standpoint, communicate at layer 3. We need to go ahead and encapsulate it. So that's why built in from a Cisco standpoint, we have those two data link layer protocols, HDLC, PPP, right? And so going back to adjacent layer communication, right? Layer 3 is going to say, hey, here's the type, right? I'm going to have a type in my header, right? Go ahead and mark that for yourself, and you know what to do from here, right? The Cisco router has in its code to say, hey, I know what to do. I know how to encapsulate this. I'm going to use HDLC. Boom, right? And so you guys are probably thinking, right? So why is HDLC more preferred rather than PPP, right? Just from my experiences, what I've seen from my mentors, what I've shadowed, examining packets, examining things online or what have you, and seeing WAN technologies in the wild, right? It's, again, less overhead, right, on the packet. I'm sorry, on the frame. Let me say that correctly because we're talking about layer 2. It's less overhead on the frame, right? And it's real simple, right? It'll do what it needs to do, get everything that it needs, put it on the wire, okay? And so let's go back to the different fields for HDLC and compare them to Ethernet, right? And so you guys seen whenever we were talking about the OSI model, and I was breaking down, and actually even with Wireshark, when I was breaking down the different fields within an Ethernet frame, right? The HDLC, data link layer 2 field is definitely similar, right, to an Ethernet field, right? You got your flag, right? It's equivalent to the preamble, SFD, right? List of recognizable bit pattern so that the receiving nodes realize that a new frame is arriving, right? Same exact thing. HDLC field, right? Address, right? Ethernet equivalent. It's only the destination address, right? And so you guys are probably thinking, well, what about its source, right? It's in the HDLC, it's only worried about making sure it gets to where it needs to properly. So it's only going to put in there the destination address. That's all that's going to be in the address field in HDLC, right? That's the difference. You're going to have your control, you're going to have your type, right? And just like I told you guys, the type section is going to say identifies the type of layer 3 packet encapsulated inside of the frame, right? And of course, we're going to have the FCS that's going to be at the trailer. That's it, right? And so this is how, from a layer 3 standpoint, right? From a router, Cisco router standpoint, let me make sure I say that, they communicate, right? On a wire, they communicate within, a WAN technology, okay? Any questions? Okay, all right. So, so let's talk about, bring it all together, how routers use a WAN data link, right? So we talk about encapsulation, de-encapsulation. You guys know about layer 3, how they communicate, IP addresses. You guys know about layer 2, right? And so this is from a high level what the router is doing, right? So again, PC1 is Mo, right? Mo wants to get to Netflix, right? Found a destination PC2, right? On Mo's PC, he's going to have a default gateway for his router, right? His PC is going to go ahead and send that to his default router, right? And from a layer 3 standpoint, layer 2, his PC is going to know, let's encapsulate it, right? And he's going to shoot it over to R1, right? Because on his ARP table, we'll get to that in the future. On his ARP table on his PC, it'll say, hey, your default gateway is this MAC address. So we know your destination, right? From a layer 3 standpoint. But for layer 2, right, your destination is going to be R1. Okay. So I'm going to send it to R1. R1 is going to say, perfect. Mo, I got what you want. I know you're trying to get to Netflix. I'm going to go ahead and rip off, right? Layer 2, header and trailer, right? And I'm going to look at layer 3. Okay, this is where you want to go. Okay, I'm gonna go ahead and send it, right? Because remember, the key point in all of this, right, in WAN technologies, is all it's providing is layer one. It's helping you get from point A to point B, just like school buses and trains, right? If I live on one side of town and I'm trying to go ahead and get to the other side of town, maybe to the food market, right? Think of buses and subways or what have you, has these switches and routers, okay? So all R1's gonna do, encapsulate it, right, at layer 3. We'll do the layer, don't change anything at layer 3, encapsulate at layer 2 using HDLC, send it over, knows where to send it over. R2 is gonna get it, de-encapsulate it, send it to PC2 based off of layer 3, okay? All right, now let's go a little bit more in detail, okay? So exactly what I was saying before, right? Mo's PC is going to act like a regular host, right? It's going to use 802.3, right? 802.3 is a standard for Ethernet, right? Layer 2, okay? So it's going to go ahead and put the standard header and trailer from a layer 2 perspective, and Mo's going to have his IP address information, right? He's trying to get to Netflix. It's going to have it right there, okay? It's going to go through the switch, get to the router, right? His PC is going to go ahead and look at the ARP table, send it over there. His router, right? It's going to rip this off. Why? Because it is not a layer 2 device. This is a layer 3 device. It doesn't know about 802.3. Has its own protocol. So it's going to use HDLC. It's going to say, hey, I got something like it. It's going to go ahead and put all it needs to get to. It's not going to change this. It's not going to change that Mo is trying to get to Netflix. It's going to change the header and trailer, right? The data link layer, layer 2, part of that TCP IP suite, okay? It's going to go ahead and send it where it needs to go to, right? R2. Then R2 is going to say, perfect. All right, so I'm going to go ahead and, smack this off, right? Because layer 1 is taken care of, right? I'm able to communicate with other routers, but now I need to go ahead and communicate to the LAN, right? I need to go ahead and communicate and make sure I can encapsulate it properly, right? So I'm going to go ahead and make sure it has the right header and trailer and send it where it needs to. Whoops, what happened? There we go. And send it where it needs to. Okay. Again, layer 3 is going to be unchanged. These routers are all in just charge of helping any of us, all of us, right, get from point A to point B. That's it, right? They communicate, right? They do same layer interaction via layer 3, right? But within it, right, it's going to do adjacent layer communication, right? So they can work together to make sure layer 1 is fulfilled. Okay? I know this is a lot, but again, got to know for the exam. Okay? And that's it for today. That's it. So this is part 1, right? There's plenty more. There's plenty more we can dive into, right? But we'll touch on that tomorrow in part 2. Okay? Any questions so far? All right, guys. Well, whenever you guys get a chance, definitely read some of the fundamentals of WAN technologies, aka Chap.3. Do the lab whenever you get a chance. And again, if you have any questions, feel free to reach out. All right, guys. Well, you have a good day.
Take care,
Thanks,
guys.
you too.
Appreciate it.
Yep.